Hello, in this video I would like to explain what cyclohexane chair conformations are, how to visualize them, and how to draw them. So now let's see how a cyclohexane, so in this case this 2D cyclohexane, which is flat, converts to our chair conformation. So all we have to do is just tilt this side up, and this side, this one right here, down. And it forms this chair, basically. So we just saw how our 2D flat cyclohexane, this one, went to a chair conformation, because it's almost like a chair that you can sit on. And you can see that if you, let's say, pretend that someone's sitting here and someone's sitting right here, their legs are coming from here and their head is tilting back onto here. So it's like a chair. But in this chair, there are several types of attachments that can happen, and they point in different directions. So there are two types of attachments. There's the axial and equatorial. Axial only means vertical in any direction, so vertical up or vertical down. And those are the only two directions, vertically up or down. So this one's axial and this one's axial. It's just this one faces down axially and this one faces up axially. And then there's the equatorial, which is basically like a horizontal, almost like horizontal, sort of equatorial on the equator. You can say equator is like horizontal across the earth. Here this is also pointing horizontally instead of vertically. So this one right here, this one, this one, this one, this one, they're all equatorial. Meanwhile, these are all axial. And now there's also a difference in what direction they point. So for example, this is axial upwards, axial upwards, axial upwards, axial downwards, downwards, downwards. And here it's equatorial, but it's trending downwards, we can see. Meanwhile, this equatorial is trending upwards. So downwards, upwards. And what we notice here is that every atom on the cyclohexane, every single atom on the cyclohexane has one of its substituents basically pointing upwards. So this is axially upwards. This one, let's say, is equatorially upwards. This one's axial upwards. Meanwhile, they all have some kind of a downwards also, pointing downwards. So this is equatorially downwards. This is axially downwards. So for any axial attachment, there's also an equatorial one on an atom. So all of these atoms, these carbons right here, these 6 of them, they have an axial in any direction. So this one, for example, has one down. And then they also have an equatorial. In this case, this is up. And that is how we would classify the atoms on here. However, here's one of the toughest parts on visualizing cyclohexanes, and that's when they do ring flips. So during a ring flip, all the up atoms, they continue pointing up. Let's say this one's going to be axial right now, but if we do a ring flip, it's going to be equatorial, but it's still going to face up. Meanwhile, this one, if it's facing down equatorially after a ring flip, it's going to face down axially. But no matter what, they continue facing in their respective directions. So let's see how that happens. So during a ring flip, yes, we will first make the 2D cyclohexane. So this one we put flat again. Same thing here. So now they're all flat. And then, so before it was like this, you could see this one facing up and then became flat. And then now we take this carbon, we point it down instead of up, like we used to, and this one up. So now you can see that here, in this chair conformation, yes, the one we just made, I'm trying to adjust it. This one continues facing up, because before it used to face up, and now it's still continuing to face up. It's just equatorial instead of axial like before. And the same thing applies to all of them. So let me just do this again, and I'll show even better how this all happens. So here we see this one's axial. And then once we flip, so let's say we're flipping this side up, let's pay attention to this one. So we're taking it, we're putting it down. But I'm just trying to adjust this molecule. But nevertheless, you can see it's still facing up. It's just equatorial. And let's take another example on this molecule. And I'll show you how this continues. So let's see. So here we have our original chair conformation. We can clearly see that there are a few that are facing up, a few that are equatorial. So let's take this one right here. It's facing up, and after I ring flip, it's still going to face up, but instead of equatorial, it's going to become axial. So watch this. I'm going to face this down. I'm going to face this up. And here we see that now this one, instead of being equatorial, now it's equatorial pointing up, now it's axial pointing up. And again, for this one, we can see now it's equatorial facing up, but if we do another ring flip, it's going to be axial facing up. So watch. See, now it's switching to axial. And the other ones are switching their positions too. So we can clearly see how this one went from axial up to equatorial up. And we can also see how this one, let's say, we tilted this one down, and this one went from equatorial up to axial up. And this one went from equatorial up to an axial up. So now it's axial up. And let's say for the white one, same thing applies. So if it's equatorial down, if we're going to do a ring flip, it's going to go axial down. So watch. See this one right here? It's currently tilting downwards. Well, it's going to go axial downwards, while the other ones are also switching their positions. So what we get from the ring flip is that these molecules, they switch from axial to equatorial or from equatorial to axial, depending on what position they were in. So this one's equatorial, it's now going to be axial. This one's axial, it's now going to be equatorial. As we saw during the ring flip, it's going to be equatorial. And this one, let's say, right now it's axial, let's say, and if we do a ring flip, it's going to be equatorial. Just, it's going to be facing, continuing to face downwards, just like it was before. So they do switch from axial, equatorial to axial, but their direction, relative direction, remains the same. So if this one was up, it's going to continue being uptrend. If this one's down, it's going to continue being down. So here it's down, now it's just more down. It's going to remain the same. So that's how we visualize the molecules changing during cyclohexane chair flip. So now I'm just going to show how to draw a cyclohexane simply. First, cyclohexane chair conformation. So first we draw a triangle. So right here, I'm just going to show a triangle, but it's no ordinary triangle. So notice when I'm drawing, I will draw it in a way that these two vertically line up. This little point right here, this end of this line, and this end, they line up vertically, because then I'll draw from them, I'll draw two parallel lines. Here's one, and here's another. And then finally, all it takes is another triangle to connect these 2 points. So you draw it up, and then you draw it all the way to this point right here. And that's our chair conformation. Now, how do we draw the substituents? That's another story. So we need to know where they will go up where they will go down. So any carbon that's facing up like this obviously is going to have one that's axially up. Any carbon facing down here is going to be down. So I'm just going to draw one facing up and one facing down substituent. That's pretty simple. Now remember that from our previous chair conformation, remember that we had for any atom, we also had an axial and we always had an equatorial for any of these atoms. So for the drawing, these axial ones are also going to have an equatorial one. So here's an equatorial and here's an equatorial. And since this axial is facing upwards, this equatorial will be downwards. And since this axial is facing downwards, this equatorial is going to be upwards, because otherwise it will get too close if you're pointing both downwards, and it will be energetically unfavorable. Now for these center ones, how do we decide which is going to have axial down, axial up? Well, the way it does, it alters. It switches one to the other. So here it's vertically up, here it's going to be vertically down for these two. Here it's going to be vertically up, and here it's going to be vertically down. So in this case we have up, so here we draw down, down, and then here we draw up, up, and now we see down here again. So it goes up, down, in terms of the axials. And how do we fill in the equatorials here? In which way? Let's say we're drawing an equatorial right here, yes? We'll face this way, we'll face this way. How do we do it? Well, we face it towards the triangle. So in this case, when we draw the equatorial right here, it's going to face in this triangle's direction, like this. And in this case, we're also going to face it in the triangle's direction, like this. So in the direction of the triangle, because the triangle here is to the right and not to the left, to the closest triangle. And in this case, let's say we need to draw the equatorial. We're not going to face it this way, because that's facing away from this closest triangle. We're going to face in the direction of the triangle instead. So like this. And then for this one, we're not going to face it this way because that's away from the triangle. We're going to face it instead towards the triangle. So like this. So let me just draw it quickly just to give you a rough idea of how to quickly draw this. So we're going to have our triangle. See, we have to make these two ends even with each other vertically. Then we draw our two lines from it. Then we're drawing our triangle up and then connecting right here down, like this. And then we're going to draw up, down, up, and down. So up, down, down. And then we're going to draw our equatorial. So here, draw one. We draw these two facing towards the triangle. We draw these facing towards the triangle, nearby it. And lastly, we draw our last equatorial right here. And that is how we draw our chair cyclohexanes.